Students, discussion चल रही है about the cyclic redundancy check or the CRC, one of the most common forms of cyclic codes that we use in the LANs and the WANs. Students, मैंने इस slide में आपको ये बताया था कि किस तरह से on the encoding side the sender encodes the data word into a code word, and then how on the receiving side this code word and the appended bits, 3 bits, they are checked, and based on the syndrome we decide whether to keep or discard the data word that was sent. Now students, because this is an important code scheme, so we are going to try to understand the cyclic code analysis or the CRC analysis by using the polynomials out here. Students, you normally know that fx is a polynomial with binary coefficients. So in this case, we are going to be allocating some polynomials to each one of the elements that we are using. So students, let's suppose that our data word is given by d of x. Students, our code word will be c of x, c as a function of x. In other words, our generator is going to be g of x. Let's suppose that our syndrome is s of x, and last but not the least, we have got our error, which is e of x. अब स्टूडेंट्स, आप लोगों ने encoding और decoding की slide में देखा था कि we have got 2 options. The first one is in which at the receiving end the sx is not equal to 0. The decision in this case is very simple. We know that the data is corrupted, and we simply go on to discard this data. Students, the second option is in which case our syndrome, 3-bit syndrome, as per our example, was equal to 0. Students, we have got 2 options out here. The first one is no bit is corrupted. So we know that we have got all zeros, so no bit is corrupted. Students, there is another option. That option is that we have got some sort of corruption, but the decoder, in this case our decoder, has not detected it. Students, we need to, in order to cater for this last case, we need to make sure that our generator function, which is gx, in this case is selected so that these particular errors that fall in this third category, they are caught as well. So students, let's try to do some maths out here, polynomial maths. So in this case, let's suppose our received code word is given by your actual code word that was transmitted, c of x, plus the error that was introduced, e of x. Students, in other words, the received code word in this case is the sum of the sent code word, which is this bit, and the error that is introduced. Students, the receiver, what it does is, using the checker, if you remember, it divides the received code word by gx. So we divide the received code word by the generator x function. So that is going to be c of x divided by g of x plus e of x divided by g of x. Students, this essentially is our syndrome. Now students, गौर कीजिएगा कि in this case, the first term on the right hand side, which is this term is actually, it has got a remainder of 0. According to our definition, when the actual code word that is sent divided by the generator function, we should get a 0. So students, in this case, this is going to be 0. So our actual syndrome will be equal to the error divided by the generator function. Students, in this particular case, as I told you, we do not have to worry about the first case, and this means that there is no error because this is equal to 0. We have to worry about the second case, and it's very important that, and the reason for that is because these are the errors that are divisible by GX and are not caught using our cyclic codes. So we need to find out some strategies by actually selecting this GX function that can take care of these errors that are not caught. So some of the advantages of the cyclic codes. First of all, cyclic codes is by far, CRC specifically is by far the best code that we have got to detect single bit errors, double errors, odd number of errors, and burst errors. Students, another advantage, one of the big ones, is the easy and fast implementation. So मैंने आपको दिखाया था कि hardware terms में implementing an exclusive or an XOR function is very trivial, which makes the implementation of CRC or the cyclic codes very cost effective and easy. Students, there are other cyclic codes as well. For example, there is a code which is called as Reed-Solomon codes behind, after the name of the scientists that have actually invented it, and that's also used, but CRC should be enough for the sake of this particular course to give you an example of how the cyclic codes operate.